Okay, now, for all those people who believe the Earth is a globe and it's not a round disc, you would know I would not need this to be under this globe. Now, but for the flat earthers, you know I need this. For example, if I put this here and I put this water, I'm just going to drop this water here. And let's see what happens to the water. Okay? Just as I thought. It's falling off the earth and going straight underneath. There you go. Hasta la vista, baby. My water left. It didn't stick. Gravity didn't pull the water to the globe. This is a good example. Then the water should pin to this, just like the weight of all that water that pins to the earth and does not fall down, but it sticks here in the North Pole. It's going all the way down to the South Pole. It's sticking. All the water sticks on there. And there's no reason for it. Because if it was gravity, then gravity should also work even on a smaller scale. It should be the same concept that the water shouldn't fall all the way down there, but it should build up and accumulate here and stick to the curb. It doesn't, because water is always level. So this is a very good reason why we've been totally deceived. And we can trust our senses just from this basic experiment of what we're seeing with our eyes. We're witnessing it with our eyes.
An avalanche is a dramatic fall of snow from the side of a mountain. They are most common in mountainous areas with repeated heavy snowfall. There are three elements which make them likely to occur: the gradient of a slope, the degree of snowfall, and the climate. When the upper layer of snow reaches a critical mass, the pressure can overcome the friction resisting it, which is lessened at the plane of weakness, and it will collapse of its own accord. Earthquakes and volcanoes can also tip the balance by shaking the ground to dislodge the snow.
Allora, agoiti costi in avalancha. Agoiti. Goiti, Aitor, contos, Aitor. Minna. Hortze! Ane, aurre, gehiago ez, Me cauen, Dios! Ane, atzeatu! Me cauen! Me cauen! Allora, Alucinante.
Här på filmen. Fytti, det är snö som kommer ned. Det är inte bara stöv ser det ut den här gången.
Det ska bli spännande att se, för det såg ut som det gick en stråle väldigt på torkesidan.
Ja, det är klart torkesidan. Jag hoppas något på igen.
Hello, Flat Earth researchers, debaters and debunkers. One of the simplest and most obvious observations that absolutely anybody can make anywhere on this Earth, that there is no science whatsoever to back up the claim that we are living on a spinning ball Earth and are stuck to it with gravity, is the fact that water will always flow down a slope or a curve. No matter how much or how little water is involved, or how steep or gentle any curve of the surface, water will always flow down any curve. The idea that a force of gravity makes water stick to a spinning ball Earth is just a figment of mathematicians' imaginations, and are stuck to it with gravity is the fact that water will always flow down a slope or a curve. No matter how much or how little water is involved, or how steep or gentle any curve of the surface, water will always flow down any curve. The idea that a force of gravity makes water stick to a spinning ball Earth is just a figment of mathematicians' imaginations,
The wet weather was also credited with this rare sight about 60 miles north of San Francisco. Lake Berryessa is filled beyond capacity, so a huge amount of water is literally flowing down the drain. Maria Villarreal shows us the phenomenon that hasn't been seen in more than a decade.
First the rain, now the drain. California's wet winter has pushed Lake Berryessa way beyond capacity, pouring water into its bathtub-like drain. It's the first time that's happened in 11 years.
Back in October, we're essentially half full. This is the first time that the lake has been so low and filled up and spilled in 1 year.
What looks calm at the top of the Morning Glory Spillway, as it's called, looks like a raging torrent at the bottom. The spillway is located 200 feet from the Monticello Dam. It's shaped like a funnel, 72 feet wide at its lip and narrowing to 28 feet at an outlet down at the Puda Creek. When water in the lake rises to more than 440 feet above sea level, it spills over the lip of this funnel and pours into the creek 700 feet below.
When this reservoir reaches its capacity, this spillway can take in about 48,000 cubic feet of water per second. That's the equivalent to draining half an Olympic-sized pool in just 1 second.
I drew a path from my dad's house in Denver, Colorado, to my house in Cincinnati, Ohio. And I want to show you something very interesting. When I choose to show the elevation cross-section, you can see it's basically this red line. The starting point at my dad's house is 5,394 feet above sea level. And he's in Denver, Colorado, which is the mile-high city, so that's what you would expect. But then as you move east, and you can see the red arrow move east as I go that direction, the landscape starts to change where the elevation drops down and continues to drop. You go from the foothills of the Rocky Mountains into the plains of Colorado, Kansas, into Missouri, Illinois, Indiana, and then finally you get into Cincinnati, Ohio, to my house, which is 764 feet above sea level. So what's interesting is Google Earth wants us to believe that the landscape makes this curve as shown here. But the elevation cross section actually shows that the landscape of the United States from my dad's house to my house follows this path. And most of us, when we were in elementary school, learned that the Rocky Mountains, which is close to where my dad lives, is the continental divide that divides the rainfall from east to west. I'm pretty sure when I was a kid, I've been to the Milner Pass, which is about 2 miles above sea level. And there's a sign that says the Great Divide separates drainage to the Atlantic from the drainage to the Pacific. It traverses America from Alaska almost to Cape Horn. And so that would make sense if the landscape does follow this topographical cross-section. I wanted to see what would happen when you look at the elevation cross-section over a great body of water. So starting at the northernmost point, as far as I can get, of Lake Michigan, and then traveling south, you can see that red line here, that the body of Lake Michigan is 574 feet above sea level, and it's level. There's no change in elevation. There's no curve. This cross-section shows what an undisturbed body of water looks like, and that's level. We know that to be true. There's 3 properties of liquids. They have mass, they take up space, and they always take the shape of their container. And so Lake Michigan from north to south is 574 feet above sea level.